This shows the oscilloscope screen. It can be thought of as a graph where the x-axis is the time and the y-axis is the voltage. It shows how the voltage varies with time. If we consider one cycle, we can measure the time for one cycle. This is called the time period. We can measure the peak of maximum voltage by measuring the height. Peak to peak voltage is the total height. If we look at the sensitivity of the settings, we can calculate actual values. Each division of voltage is worth 10 volts. So in other words, each one of these divisions going up is worth 10 volts. Here we can see for the time, sometimes called the time base, then each division this way is 12 milliseconds. It is important that we check what units this is measured in. Here we can see that one cycle is 2.6 divisions. 1, 2, 2.2, 2.4, 2.6. Therefore, the time for one cycle is 12, because each division is worth 12 milliseconds, times 2.6. So the time period is 31.2 milliseconds. We can convert time period to a frequency, which is the number of cycles per second, as follows. The frequency is equal to the 1 over time period, or 1 divided by time period. Putting in the value for time, remembering to convert the milliseconds to times 10 to the minus 3, then we can calculate the frequency as 312.5 Hz. We can see peak voltage is 3 divisions. Because the sensitivity says that each of these divisions is worth 10 volts, then we can work out the peak voltage as 10 times 3, which is 30 volts. Note, the peak to peak voltage is always double the peak voltage, so in this case it will be 60 volts.